For question 1, part A, I'll use the formula for the nth term of an arithmetic sequence that states the following: a plus n minus 1 d. A is the first term, in our case 1, and d is the common difference. That's the amount by which you increase or decrease every time. In our case, it's positive 4. So if I substitute these numbers into the formula, I get 1 plus n minus 1 times 4. Let's expand. 1 plus 4n minus 4. And if I simplify, I will get 4n minus 3. For part B, I'm given the nth term of another sequence. Note that n becomes 3n plus 5. So if I want to find an expression for the 2mth term of the sequence, I'll take the 2m, multiply this by 3, add 5, and simplify. This will give me 6m plus 5. In question 2, I'll start by finding the probability the spinner lands on 2 or 4. I will let this be x, so 0.26 plus x plus 0.18 plus x must be equal to 1. So 2x is equal to 0.56. X comes out to be 0.28. Then I'm going to use the following formula. Estimating the number of times it lands on any number is equal to the probability of getting that number times the total number of spins. And I'm going to do this twice, one for 3 and one for 4. So using the formula for number 3, 45 times is the estimate. This must be equal to 0.18, which is the probability, times the number of spins. So n is 45 over 0.18. n comes out to be 250. And then using the same formula for number 4, I will have 0.28 times 250, and my answer will come out to be 70, which is my final answer. For part of question 3, I'll write 56 and 84 as the product of prime numbers. So 56 divided by 2 is 28, divided by 2 is 14, divided by 2 is 7, divided by 7 is 1. So 56 is equal to 2 to the power of 3 times 7 to the power of 1. Let's repeat for 84. Divided by 2, it's 42. Divided by 2, that's 21. Divided by 3, it's 7. Divided by 7, you get 1. So 84 is equal to 2 to the power of 2 times 3 to the power of 1 times 7 to the power of 1. And then to get the highest common factor, I will write down all the prime numbers that are common to their lowest powers and then multiply these together. So 2 to the power of 2 times 7 to the power of 1 will give me 28. Both these are accepted. For part B, I will repeat the procedure with 60 and 72. 60 divided by 2 is 30, divided by 2 is 15, divided by 3 is 5, divided by 5 is 1. So 60 is equal to 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1. For 72, divided by 2 gives me 36, divided by 2 gives me 18, by 2 gives a 9, by 3 gives a 3, and finally 3, 1. So 72 is equal to 2 to the power of 3 times 3 to the power of 2. For the lowest common multiple, I will multiply together all prime numbers to their highest powers. So I'll multiply 2 by 3 by 5. The 2 will be to the power of 3. 3 to the power of 2 and 5 to the power of 1. This gives me 360. Both forms are accepted. For question 4, all these three angles should add up to 360. So 7x plus 8x plus 3x equals 360. So 18x equals 360. X comes out to be 20. Now I'm given that polygon B has n sides. The interior angle of polygon B is 140 degrees. So I can use the following formula. So 140 is equal to n minus 2 times 180 over n. Let's cross multiply and expand the right hand side. So 180n minus 360. I will rearrange, get 40n on the right, 360 on the left, and if I divide, n will come out to be 9. Now, alternatively, since the interior angle is equal to 140, you can find the exterior angle, which is 180 minus the interior. So the exterior is 40, and you can use the following formula. So 40 is equal to 360 over n. So n is 360 over 40, which comes out to be 9 again. For part A of question 5, I'll expand term by term. So I've got n squared plus 4n minus 6n minus 24. You simplify, you get n squared minus 2n minus 24. For part B, I'll start by cross multiplying. So I get 8x minus 12 equals to 3x minus 5. I will collect x terms on the left, so 5x, and constants on the right, so minus 5 plus 12 is 7. So x is 7 over 5, which is my final answer. For part A of question 6, I have 4% increase, which means I have a multiplying factor of 104 over 100. As a decimal, this is 1.04. So now I will use the following formula. Initial times the multiplying factor gives me the final value. So the initial value times 1.04 must be equal to 634400. If I rearrange, initial value is equal to this number divided by 1.04. Put this in the calculator and you will get 610000. Note that this is still in the same band. Hence, there is no band change. In part B, I have a depreciation of 15%, which means that the multiplying factor is 85 over 100. As a decimal, that's 0.85. Now, this is for 2 consecutive years, so the overall multiplying factor is 0.85 squared, 0.7225, and note that this can be written as 72.25 over 100, which is a decrease of 27.75%. Alternatively, for this part, you can use the formula for the multiplying factor, which is the following: 100 minus the rate over 100, which is pretty much what I've used here. So apply this to the 0.7225. 100 minus r over 100 equals 0.7225. Cross multiply, this will give you 72.25, and if you rearrange, you get the same answer. For question 7, I'm given this cylinder. I know the height, I know the force on the ground, and I know the pressure. Now note, in this formula, pressure equals force over area. The area is not the total area of the cylinder, but the area that is in contact with the ground, which is this one. And that is a circle with an unknown radius. So I will use the formula pressure equals force over area to find the area, and then use the area to find the radius. So let's begin. Pressure equals force over this area. 1.4 equals 72 over the area. So if you cross multiply, area is 72 over 1.4. That's 360 over 7, which is equal to 51.4, and so on. Now I will use the area for the circle, which is the following. So pi r square is equal to 360 over 7. R square is equal to 360 over 7 pi. So r is equal to the square root of 360 over 7 pi. If you want this as a decimal, that's 4.04, and so on. Finally, I will use this radius to find the volume of the cylinder. The formula for the volume of the cylinder is the following. So volume equals pi 4.04 and so on squared times 18. Put this on the calculator, and the answer you get is 926 centimeters cubed, correct to 3 significant figures. Note that the mark scheme accepts answers between 925 and 928. Part of question 8, the answer is 8.9 times 10 to the minus 5, and for part B, that's 834. I've used 2 digits from 10. I need another 2, so 83,400 is the correct answer. For question 9, 40 to the power of 0 is equal to 1. 8 times 1 is equal to 8. For part B, note that because I have division, I need to subtract the powers. So x to the power of 6 minus 5 becomes x to the power of 11. So P is equal to 11. And then for part C, I'll need to split this into 3 different terms. So 2 to the power of 3 times k squared to the power of 3 times m to the 4 to the power of 3. The first one gives me an 8, and in the other two I'll multiply the powers, so I will get k to the power of 6, m to the power of 12. For question 10, I'll start by using the distance formula to find the distance between the two centers. The formula is the following. So let's plug in the values. This will give me the square root of 18 minus 3 squared plus 7 minus 1 squared, and the answer comes out to be 17. For part B, I'll need to investigate before I answer. Consider the following 3 cases. In all 3 cases, I have 2 circles. The red line is the radius of the big circle, and the blue line is the radius of the small circle. And the distance D in orange is the distance between the 2 centers. In the first case, the distance is bigger than the sum of the two radii. The orange line is bigger than the sum of the red and the blue. In the second case, the distance is exactly the same as the sum of the two radii. And in the third case, because of the overlap of the two radii, the distance d is less than the sum of the two radii. And in the first case, the circles do not overlap. In the second, they just touch one another. And then in the second one, they overlap. And we want to explain why the circles intersect. And basically, I'm going to compare the 17 I found above, which is the distance between the two centers, with the sum of the two radii, which is 13 plus 6, 19. And in our case, 17 is less than 13 plus 6. So we fall in the last category, which means that circle C1 intersects with circle C2. So let's write this down. You could also write this in words, something like distance between the centers is less than the sum of the radii. In part A of question 11, just recognize this as the difference of two squares, so the two factors will be 3x minus 2y and 3x plus 2y. In part B, I'll need to merge this into one fraction. I'll multiply the first by x and the second by 2. My common denominator will be 8x. And then I'll have 7x minus 2 times x plus 3. Now, if I expand, I'll get 7x minus 2x minus 6 over 8x. And this simplifies to 5x minus 6 over 8x. And that's the final answer. For question 12, I've got a 0.8 probability of using the treadmill, which means there's a 0.2 probability of not using it. If you use a treadmill, the probability that you'll use the cross trainer is 0.3, which means there's a probability of 0.7 of not using it. And the corresponding probabilities below are 0.6 and 0.4. Now for part B, the probability to use both is 0.8 times 0.3. This will give me 0.24. I'll start question 13 by adding payment 1 and payment 2. So 3/8 plus 45 over 100 will give you 33 over 40. You can do this on the calculator. That means that payment 3 is the rest, which is 7 over 40 of the total amount, and this corresponds to $406. Now payment 2 is 45 over 100 of the total, and this is x dollars. So now I will just cross multiply, hence x equals to 45 over 100 times 406 over 7 over 40. Put this on the calculator and you'll get 1044, which is my final answer. For part of question 14, I'll just substitute 10 in place of x. So f of 10 is equal to 2 times 10 over 10 minus 6. Plug this in the calculator and you'll get a 5. For part B, start with the function y equals 2x over x minus 6. Now swap x and y's, so x equals to 2y, y minus 6, and now I want to make y the subject. I'll start by cross multiplying, so xy minus 6x equals 2y. I will collect the y's on the same sides. I'll take them to the left, so xy minus 2y equals 6x. I'll factorize the y out, so y bracket x minus 2 equals to 6x, and finally y equals 6x over x minus 2, and this is the final answer. Note that the mark scheme also accepts an answer of minus 6x over 2 minus x. For question 15, to get a total score of 0, you should have 1 win and 2 losses or 3 draws. So if I write down the probabilities, that's probability win, lose, lose, plus the probability lose, win, lose, plus probability of lose, lose, and then win, or probability draw, draw, and draw. Now, for the first one, probability win, then lose 2 consecutive games. This comes out to be 0.3 times 0.2 times 0.2. Now, note that the first 3 probabilities have the same numbers but in a different order. So the sum of these probabilities will be the probability of the first one times 3, and this comes out to be 0.036. And then the probability of getting 3 draws in a row is 0.5 times 0.5 times 0.5, and this comes out to be 0.125. And if you add these 2 probabilities, you will get 0.161. For question 16, I'll start with the first term of the left hand side, 12 over square root of 2 minus 1. Now, to simplify this, I'll need to rationalize the denominator, which involves multiplying top and bottom by the same thing, and this will be square root of 2 plus 1 in order to create the difference of 2 squares in the denominator. So the denominator will be square root of 2 times square root of 2 is 2. Then this expansion will give me root 2. This one will give me minus root 2. They will cancel out. And the final expansion will be minus 1. And then in the numerator, I get 12 times square root of 2 plus 1. If I expand the numerator, I'll get 12 square root of 2 plus 12. The denominator is 1, so no need to write it. For the second term of the left-hand side, square root of 2 to the power of 5. Consider this to be square root of 2 squared times square root of 2 squared times square root of 2 to the power of 1. The sum of the powers is equal to 5. Now the first one, square root of 2 squared, gives me a 2 because the square root and the power of 2 cancel out. Same with the second one, the last one stays the same, so this gives me 4 square root of 2. So the left hand side is equal to 12 square root of 2 plus 12 minus 4 square root of 2, which gives me 8 square root of 2 plus 12. Now the right hand side is equal to 2 square root of 32 plus 12. The square root of 32 can be split into square root of 16 times square root of 2. The plus 12 stays there. Now the square root of 16 is 4. So I've got 2 times 4 square root of 2 plus 12, which is 8 square root of 2 plus 12. And note that the left-hand side is equal to the right-hand side. Let's write this down. LHS equals to RHS as required. For question 17, I'll start by writing S in the form 4t squared plus 125 t to the minus 1. And then to find the velocity, I will differentiate S by t, which will give me 8t minus 125 t to the minus 2. Now I can rewrite this as 8t minus 125 over t squared. Now, if the velocity is 0, I'll have to solve 8t minus 125 over t squared equals to 0. I'll take the 125 over t squared to the right, so 8t is 125 over t squared. I will cross multiply, so 8t to the power of 3 is 125. T to the power of 3 is 125 over 8. So t is the cube root of 125 over 8. That comes out to be 5 over 2 or 2.5 seconds. Hence, the displacement or distance is equal to 4 times 2.5 squared plus 125 over 2.5. Put this on the calculator and you'll get 75 meters. For question 18, I'll have to use the cosine and sine rules. First, I'll use the cosine rule to find the side AC, and then once I find AC, I'll use the sine rule to find angle X. So let's begin. AC squared is equal to 9.7 squared plus 12.3 squared minus 2 times 9.7 times 12.3 cos of 115. So AC squared is equal to 346.2 and so on. So AC is the square of that, which gives me 18.6 and so on. And then moving on to the sine rule, sine of X over 9.7 is equal to sine of 115 over 18.6 and so on. So sine of X is equal to 9.7 sine of 115 over 18.6. Now put this on the calculator using the exact value of 18.6. This will give me 0.472 and so on. So X equals the inverse sine of 0.472. Put this on the calculator and you'll get 28.2 degrees. For question 19, I have this sector with radius r plus 7 and the angle is 45. Circle C has a radius of r minus 2. Here is the circle. And the area of S equals 2 times the area of C. Let's write this down. Now the area of the sector is 45 over 360, which is the angle, times pi r squared, so times pi r plus 7 in this case squared, 2 times the area of the circle, which is pi r squared, but the radius we're going to use is r minus 2. So let's start by cancelling out the pi's. 47 over 360 is 1 over 8. Let's expand. r squared plus 14r plus 49 equals 2 times r squared minus 4r plus 4. I'll take the 1 over 8 to the other side. It will be times 8. So r squared plus 14r plus 49 equals 16. R squared minus 4r plus 4. Keep the left hand side the same and expand the right hand side. So 16r squared minus 64r plus 64. I'll take everything to one side. I'll take everything to the right hand side. So I'll get 15r squared minus 78r plus 15. Now I'll divide by 3. So 0 equals 5r squared minus 26r plus 5. And then I will factorize 0 equals 5r minus 1 times r minus 5, which means that r is equal to 1 over 5 or r equals to 5. Now note that both of these must be positive, so r plus 7 is greater than 0, which means r is bigger than minus 7, and r minus 2 is bigger than 0, so r must be bigger than 2. So I will reject the 1 over 5, and my final answer will be r equals to 5. In question 20, I have two transformations. The first one is a translation by 2 units to the right, and the second one is a stretch along the y-axis by a scale factor of 3. So for the first one, I will take the graph 2 units to the right, which means that I will add 2 to the x coordinates. So for the turning point, I have s plus 2 and the y stays the same. For part I will keep the x coordinate of the turning point the same, and I will multiply the y coordinate by 3, so I'll get 3t. For question 21, I have this histogram. I'm given that the frequency for the first group, this one, is 10, so the area of that is equal to 10. Now the base is 20, let the height be h, and hence the area is 10, so 20h is equal to 10. H is 1 over 2, or as a decimal 0.5. So now I can complete the vertical scale, since every 5 small squares is 0.5. Now I need to find an estimate for the number of children between 50 and 80, which is this region here. Now this region is made up of 3 bars. The first one goes from 50 to 60, the second one goes from 60 to 75, and the last one from 75 to 80. The height of the first is 2.9, the height of the second is 3.2, and the height of the last one is 2. So the total area is given by 10 times 2.9 plus 15 times 3.2 plus 5 times 2. And if you put this on the calculator, you will get an answer of 87. For question 22, I'll need the formulae for the cone and the hemisphere, which are the following. I'm given the curved surface area of the cone. I'll use that to find the slant height, and then I'll use Pythagoras to find the height of the cone, and from that point I can find the volume of the whole shape. So let's begin. Curved surface area of the cone is pi RL, which is equal to 580 pi. Now the radius is 20. Let's put this in. So L is 580 pi over 20 pi, which comes out to be 29. So that's the slant height. So now let's find the height of the cone using Pythagoras theorem. H square plus 20 square is equal to 29 square. So h square is 29 square minus 20 square. H is the square root of that number, which is 441, and this comes out to be 21. So now let's find the volume. I have half a sphere, so 1 over 2, 4 over 3 pi r cubed plus a third of pi r square h for the cone. Now the 4 and the 2 simplify, so I've got 2 over 3 pi 20 to the power of 3 plus 1 over 3 pi 20 square times 21. If I simplify this, I get 16,000 over 3 pi plus 2,800 pi, and if I add the coefficients of pi, I will get 24,400 over 3 pi, hence the value of k is 24,400 over 3. In question 23, I'm given the first 5 terms of a sequence. Now, I don't know how many terms there are in the sequence. This is what I'm trying to find. What I do know is that, firstly, these numbers are the interior angles of a polygon. So the sum of the interior angles is given by the following formula. Furthermore, I'm given that the values form an arithmetic sequence, the sum of which is given by the following formula. So since both of these hold, if I create 2 expressions and equate them, I'll have an equation, and when solving that, I'll be able to find the value of n. Starting with the left equation, the sum is given by that expression. If I expand that, I'll get 180n minus 360. That was the easy part. Let's go to the right one, the arithmetic sequence. Now the first term is given, it's 177. The common difference is minus 2 because each term is 2 less than the previous one. So if I set up my equation, this will be n over 2, 2 times 177 plus n minus 1 times minus 2. Let's simplify this. N over 2, 354 minus 2n plus 2. I'll simplify the brackets. N over 2, 356 minus 2n. And if I expand, I'll get 178n minus n squared. As I said before, these 2 expressions must be equal. So this is the equation I will create. 180n minus 360 equals to 178n minus n squared. This is a quadratic equation. I'll take everything to one side. So n squared plus 2n minus 360 is equal to 0. Now I'll solve this by factorization, although you can solve it any way you like. N minus 18 times n plus 20 is equal to 0. So n is equal to 18 or n equals minus 20. I can have minus 20 terms, so I'll reject the negative and I'll keep the 18, and this is my final answer. For question 24, I'll need to express this in this form. Now there are two ways to do this. I will either complete the square or compare coefficients. I'll do both methods. I'll start by completing the square. So I'll write the original expression in descending powers of x. So minus qx squared plus 12x plus q. Now I'll take a factor of minus q from the first two terms. So minus q square bracket x squared minus 12 over qx, and then plus q outside the bracket. Note, because I've taken a minus q outside the bracket, the plus here turned into a minus. Expand to confirm. Next, I'll proceed to complete the square for this expression here. So let's come to the side, rewrite the expression x squared minus 12 over qx. Now this is equal to x minus half the coefficient of x, and half of minus 12 over q is 6 over q square, and then minus 6 over q again square. If I expand the second bracket, I'll get minus 36 over q squared. So let's return to the left. This is equal to minus q square bracket. I'll rewrite the thing in blue. X minus 6 over q squared minus 36 over q squared. Close the square bracket plus q. Next step is to expand the square bracket. So minus q times the bracket. And then I'll have plus and do this expansion. That's 36q over q squared plus q. I can simplify this. Minus q bracket x minus 6 over q squared plus 36 over q plus q. Finally, I'll write it in the correct order. 36 over q plus q minus q bracket x minus 6 over q squared, which means that a is 36 over q plus q, b is the letter outside the bracket, which is q, and c is 6 over q. As I mentioned before, there's an alternative way to solve this. This is my original expression, but this time I'll start with the target expression, which is a minus b x minus c squared, and I'll expand this. A minus b times x squared minus 2cx plus c squared equals a minus bx squared plus 2bcx minus bc squared. And if I write in the same form as this one, constants, then the terms of x, then the terms in x squared, I'll get a minus bc squared plus 2bcx minus bx squared. Then I'll proceed and equate coefficients. I'll start by equating coefficients of x squared. In the original expression, I've got a minus q. In the final expression, I have a minus b. So minus q equals to minus b, which means that b is equal to q. I will then equate coefficients of x. In the original expression, I have plus 12. In the target expression, I have 2bc. So 12 equals 2bc. Now b is found to be q, so 12 equals 2qc, which means that c is equal to 12 over 2q. If you simplify this, you'll get 6 over q. Finally, I will equate constants. In the original expression, I have a q. In the target expression, I have a minus bc squared. So q equals to a minus bc squared. A is equal to q plus bc squared. I know b and c. Let's substitute. Q plus q, 6 over q squared is equal to a. So q plus q times 36 over q squared equals a. So q plus 36 over q is equal to a. And note that the three answers we found, A, B, C, agree with what we found before.